Okay, so I have solved this question before, and I'll try to give my opinions one more time on this question. So this is asking us find number of good pairs. What is meant by good pairs? It will explain here. We are given an array of integers, nums. Array is called nums. As we can see, we have some examples here. So it's asking us to return number of good pairs, not the pairs themselves. Mhm.
Yeah. Okay, no problem. Mhm. Hello, guys, here again. Today's session is uh, session 5, and we have here Kuvonchbek Normakhmatov, who is software engineer at Exadel. He's an experienced developer and passionate about solving problems on Leetcode and other on different like platforms, right?
Yeah, but mostly on Leetcode.
Let us introduce yourself a little.
Okay, as he mentioned, I work at Exadel. I work as a Java backend developer. And apart from my main job, I try to solve these kind of algorithmic questions on different platforms, but mainly on Leetcode. That's because it has really good problem set as well as really good UI. As we can see, it's really good for reading the problem,
Mm,
answering the problem, and checking and debugging that kind of stuff. Everything we have in one platform. So today
okay.
we'll be talking about this problem, which is called number of good pairs, and this is hash table topic problem. Here we will be trying to solve this problem with multiple ways. First, I'll try to give the dump solution first, where you also need to do such when you are uh, making an interview for tech companies. It's a good
Mm,
approach to give the dumper solution like first and try to optimize your solution as you go. Okay, so let's get to the problem itself. It says we are given integer array which is called nums, and we need to return number of these kind of good pairs. Good pairs is a pair. It explains here. So what is good pair? Good pair is a pair. We have j. It's called good if and only if nums I is equals to nums j. What it means? We are given, as I told, we are given array and we have multiple numbers. It might be like 1,000 numbers. It might be actually we know how many numbers we are gonna given. Here it's shown like we might be given lengths from 1 to 100, both inclusive. So and also numbers themselves are like could be from start from 1 until 100. Okay,
mm,
so what it is asking, we need to find such match. Here means like two numbers, basically. We need to find two elements where we have these elements equal to each other. So if you look at this example, it's always good to look at example. Like even if you do not understand the question itself, or if you do even if you do not look at sometimes, I mean sometimes not always, do not look at the problem, but if you look at the example, you can understand most of the times understand what problem is asking from you. Okay, so
mm,
we are given three examples here. First one is like as I said, we need to find the equal numbers that matches like pairs. Here, for example, what is it's asking? What it's like giving solution like it says there are four good pairs, 0 and 3. If you look at here, array index, as we know, starts from 0, and it will be like next one will be 1, next one will be 2. I'm talking about index, not actual number. So this will be 4, fourth index, this will be 5 index, and this will be 6 index. Okay, so
mm,
first match, first pair we have is a zeros index and third index. If you look at here, we have 1 here, and if you move here towards the right, this will be 1, this will be 2, this will be 3. Third index, I mean. As you can see, we have 2 equal numbers. This is a good pair. The problem it's and also if we move further, we have also this number, which can also be good pair with this one. So far we have 2 good pairs. We can also see from the explanation itself. It's taking 0 and 3, it's taking 0 and 4 for here.
Mm.
So what about next one? What about next one? Okay. So we took all the ones for this one. But if you look at here, this one could be good pair with this one as well. These 2 numbers could be
Yeah,
good pairs, basically. Yeah. And
yeah.
also,
There are two good pairs for one, right? Which is
yeah,
place it at
no.
first
Actually,
index.
it's not 4. I mean, it's not 2, it's 3.
Yeah,
For
three.
this
Yeah.
one, this one also can be good pair. This one also could
Mhm.
be good pair, yeah. But
Yeah,
for this one, only this can be good pair, right?
yeah.
Why we are not taking this one and this one again? First take this one and this take one. Why not this one? This way, this approach. Because we're given
Mm.
some statement here. It says I should
Mhm.
always be smaller than j. Is index. So when we are choosing
Yeah.
2 numbers, I always should be less than, smaller than j. That is a requirement we are given. Okay.
Mm.
And then we can okay, this no states here. Usually we are given constraints, all the constraints here also. Okay,
Mhm.
so we have taken all the good pairs for 1. Okay, everyone understand, right? If you have any questions, don't hesitate to ask questions in the comment section or chat section. I don't know.
Yeah.
Uh, let's go on. What about the next one? As you can see, we have this 3, and the next 3 is here. I mean, we don't have any match good pair for 2, so that's why we have to move to the next element, right?
Mm.
So we have given 3 here, and there is good pair for 3 here. So the explanation also, we are dated like this. We're shown like this, yeah. This is the
Mhm.
second index, and this is the fifth index.
Okay.
Okay, so this is like we, the human, can identify these things, but we need to write such an algorithm which will just get any array, any type of array, and it should find this kind of matches. So this is algorithm we need to write. If you do it like fixed one, like if you do it like if dot length equals what 6 and return 4. What about other cases? We might
Mm.
given like 100 test cases. So this is just one test cases, right? So we need
Mhm.
to write such an algorithm which will suit every type of nums array, right? It work for all of
Yeah.
them. Okay, this is what this algorithm is all about, actually. Okay, so let's try to give pseudocode first, and I will try to give the code itself, right? So pseudocode will be first thing that comes to mind when we are looking the most of the array problems is a brute force. Brute force is we just look at each case. I mean, we take this one, the first number, the first index. We look at the each number one by one. In this case, let's write the number itself like the array. What we will do in the brute force case is that we take like 1, then we take 2, right? And we take 1, it's 1. We need to look at all of them, like 1 and 2. Then what? 1 and 3, 3, yeah, and 1 and
Yeah.
1. This is the brute force. So uh, here it's called. If you look at the bigger notation, it will be like n quadratic. I don't know how to say like what is the term I couldn't remember. So this is not a good time complexity here. Okay?
Mm.
So we need better time complexity here, which will work like faster than this solution. In this
Yeah.
case, we have to iterate the array itself like 10 times. For this one also, we have to look at all the numbers. For this one
Mm.
also, we have to look at all the numbers until the end. Okay, so let me like give you the brute force code itself. Then I will try to move to the better solution, of course. So what we'll do basically, we just need to counter, right? Counter variable. Why we need counter variable? Because we need to find the number of good pairs. When we're asked number, count how many, that kind of questions, we always need to counter because we need to calculate, we need to calculate how many times it will occur, so to say.
Mm.
So I will just open some variable. You can just do it in your language as you want. I don't know how it will be in some other languages, that doesn't mean. Okay, so we are opening some counter variable here. Let's just call it counter because it will count the number of pairs. Okay, so what we will do, first we need a variable for the I that's shown here. Oh, so it will uh, be until num's length, basically, right? You
Yeah.
might think like that, but we will see why it will not be nums dot length. Okay. So then we also need the another pointer. This is a pointer actually. When we are
Mm.
pointing to the first number, we also need the second pointer, which will check for second pair, right? So
Yeah. One by one. Take this.
yeah. We can do it multiple ways. We can just open some variable here, like we can start from 0. This will be like second pointer, but better
Mm.
approach is I prefer to use uh, what second for loop. So it will start from let's call it j. It will start from not from I because we are given constraint. As I told,
Mm.
we need to start from at least one element, one index, right? Right. So that's why
Yeah.
we will take it like I plus 1. So it will start from next element. And it should also go uh, until the last element. But there is one problem here, you will see.
Okay.
So it's always better to experience the problems, exceptions, and you will understand it better. So what we need to do, let's just get the first number, first pair, let's say, first pair. What is it? It will be nums I, okay?
Sorry.
So first pair will be, let's take like, well, this could be this one, and it will be this one, 2, it will be 3, it will be 1, it will go like this. And what we're gonna check, so we also need the second pair, right? So it will be what? It will be nums.j. By doing that, here what we are doing like when it's 0, when I is 0, it's index 0, right? So index 0 number is 1 in our case. So in the first iteration of I for loop, it will be 1. But for
Mm.
j, it will not start from 1, it will start from 2. Why? Because we made it so I plus 1. Whenever we start from some number, let's say from here for I, it will be starting from next element, basically next index, we can say.
Mm.
Okay. What we want to find, we want to find good pairs. So we need to check, we need a statement. So we are
Yeah.
gonna check like this. Do you
We
have some
just
questions?
gonna compare with each other.
Yeah,
Just the
sure.
difference with the difference of one element, right?
Yeah.
Yeah.
No.
Good.
Not only this next element. When we
Mm-hmm.
move when we are keeping this the certain index for I, they will
Mm.
go until the end. Each iteration of I. When we do, I
Mm.
told, when we choose one first index for I, J will start from second index until the last index, right?
Mm.
Here we are stating it like that. We need to look each index, each match, each pair, and it will take a lot of time. When we,
Yeah.
for example, it will also increment, right? We are taking this element, for example, for I, for the first pair, the same thing. They will start from the
Mm,
next element and it will go until the last element. It's the same. When I choose this one for I, all right, then we're gonna start from here for J. I
mhm,
mean, we're gonna look at each of them for J. It's always the
mm,
case. So what we need to do, we took the first number, we took the second pair, second number, and now we need to check. We need to check if they are equal. This is easy to start. First pair, if first pair is equal to the second pair, then what we want to do?
mm.
Return one? Yeah, no. So we want to calculate such pairs, like all of them. So that's why we opened this variable. This variable for so to say, accumulator of this kind of count of these pairs, this type of pairs. So what we want to do, we just want to increment count. We can do like this, for example, or we can do it like plus plus. So
Increment. Mm,
yeah. So at the end, what we want to do, we just want to return this counter. How many pairs we had, it will accumulate and it will return the pairs, number of pairs at the end. Yes, that's
yeah.
it basically. We are gonna run the problem. We will see the error, I think, or not. It
Mhm.
will happen
So,
sometimes. Let me submit it. When we do submit, it will do it for all the test cases. We might be given
yeah.
like 1,000 test cases, but for run, we are
Mhm.
only given 3 of them.
Wow.
Sometimes it doesn't work because when we are looking for, let's say, it will go until the last index for I, right? Let's see.
Mm,
When we are choosing this one for I, right, since it will go until the last index, then what will be the J? So there is no point actually checking for uh, last element for I. We always need to find the
mm.
second pair right to it. So there's no point checking for this number. I mean, it will
Yeah,
not
it's
make
not needed.
that big difference, but
Mm,
correct way would be just doing -1 for this. Why? Because okay, let me explain it. Some people might not understand it. Like, for example, length here for us here is at 6, right? When we do nums dot length, it will be 6, but we don't have less or equal. We only have less, right? In our previous case,
mm,
it was like this. What's doing? So it will not check for sixth index. It will only check for fifth index at the last point for I.
mm.
At that point, they should start from 6. That's what we are saying. It's like doesn't make sense because we don't have the sixth element here. That's why I am saying we need to look at like this -1. So what will it do? Length is 6. When we subtract 1 from 6, it will be 5. So it will check until the fourth index, which will be this one, I think, right? 0, 1, 2, 3, 4. This is for I, and then will be this one, and it will work only once. Okay, I tried to explain as I could. This is not a good approach. This is not the best algorithm that could be written. What would be
Yeah.
the best approach here?
Okay. Kuvonchbek, and
Yeah,
come back again, asymptotic analysis. I mean, time and space complexity for this approach in order
okay.
to explain to all newbie programmers, right? Because a lot of
Actually,
people, yeah,
yeah,
complain about this
to your,
approach.
to your question, I
Mhm.
actually already explained this thing in my last
Yeah.
session. I think that's in the like in your channel. At least
Mhm.
I hope so. So there is no point me repeating myself since we have the time constraint also. I
Yeah.
mean, I can explain what quickly, but not from scratch in like explanation of 30-minute session.
Mhm.
Okay, so
Yeah.
let's do
Okay.
it quickly. They told here
Okay.
why it's called O the O n to the point 2, right? Like a quadratic, I think. I couldn't remember the term. So why it's called? Because we are, for each element, we are checking all the elements, right? For this one also, we are checking all the elements. For this one also, we are checking all the right elements. We are not checking the elements only once. When we do like, when we check for one, we are doing 1, 2, 1, 3, as I already explained here. 1, 1, right? This is not of n, right? This is of n to the square.
Mm.
That's why it's bad. It might not be bad for this example. I mean, it's because we are only given 100 as a constraint, but sometimes we might be given million as a constraint. That is when the problem occurs. And most of the time, for harder problems, we will get the time limit exception, time limitation exception, or something like that. And Leetcode also, in when we use this kind of approach in our projects will like work really with bad performance. That's not good. Always good to choose a better approach, better optimized approach. So, what is the second approach? What is the next approach? How can we optimize this algorithm? Right. Best approach here is that I mean, not the best approach maybe, but I think it's best just looking at the elements once and that's it. When we look at this element, we don't look at the sixth element anymore. We move to the next one. Then we move to the next one. Then we move to the next one. And it will end like that. Sorry. So I think we need to use a hash map here, hash table. Uh, and if you look at the problem topic also, it states it's recommended to use hash table here. So let's get to actually solution itself. What I'm gonna do, I'm gonna store each element, its frequency to the hash map, right? So for the first element, I will look at like this. One, do we have the one in our hash map? No. So what we will do, we just add it. One and its frequency also. So far we had only
Mm.
once occurred, right? And the next one, we are given two. What we will do with it? We just look at like two, many times it occurred. It occurred only once. Then the next one, three, once, one. What will it be? Will it like one, one? No, because we already seen the one. So by this point, we already seen the one, the number element one, two times, twice, right?
Mm.
So for this one, it will be updating the hash map value when its key is equal to one. It will update it by two, and for this one, it will update by three. Because by this time, one has occurred three times. That's why we need to update it. And for this one, for three, do we have already the T three? Yeah, we have. So we just increment the value. So this is what we have at the end of the incrementation. That's it. We only look at each element once. We didn't look at multiple times as we had before in this case. So what will be the time placed here will be O of n, right? It will be O of n. And one thing we need to look at here is that whenever we have the element before, we have occurred this element before, we need to add it to the counter, right? For example, what I'm saying. Okay, so let's look it from scratch. So when we take one, so one, right? We cannot do anything with it because it's not here. It just occurred once. For next one, two occurred once as well. Three occurred once as well. But for this point, what we have here, right? We have one, and here also we have one. How did we know? Because we have not one here, it will be two. That's it for what we want to do. Okay, a moment. We need to check the if element has occurred before, and if element has occurred before, we want to actually add this value to the counter, because this is how many pairs it could be formed. For this one, for example, yeah. So it will be 3, right?
Yeah.
Then we need to add it to the counter also. And for 3 is the same case. It will be 2 in our case. Okay, so do we have time still, or may like I'm slow?
No, continue. Go ahead. Yeah,
Great.
we have to complete the second approach.
Okay. Uh, so what we will do? Okay, so we will do it like this. I will remove this code. Don't you maybe like pass this solution to some like comment section or not?
No.
Okay, everything is here. You can just screenshot it and use GPT maybe. You know, it's code. Okay, we'll open the hash map and it will be like integer, because why it's integer? You wanna keep the element and it's integer, and the frequency also integer. That's why we will do it like this. And its implementation is hash map, and we don't need the second for loop. We only need the first one, and we wanna check this until the end, not to the like one before the last index. Okay, what we wanna do? First, we wanna check if map already contains the key, and the number. What is the number? Current number is nums.I, nums I. So we are looking at each number, right? In this case. So we are gonna check if the number is already existing in the hash map, and if it exists, what you wanna do? If current number exists in the hash map, we want to get the number, right? Let's take it like value. We want to increment the value by 1, okay, and put it to the hash map. But before we do that, we also need to add it to the counter. Here we need to counter. Count plus equals value. And we need to, or we can do it like this. Map dot put it will be current number, and the value will be value plus 1. As I explained here, we don't just want to put the previous value. We want to increment it and put it, right? Okay, what about the case where we don't have the key already existing in the hash map? Then we just want to put the like current number, and frequency will be what? Frequency will be 1. Sorry. Okay, and we will be calculating all the sorry. We will be calculating all the counters, all the pairs, and we will be returning the counter. In our case, it will be count, CNT. Okay, here we can see we are getting the correct answer. This is much better approach. I mean, I cannot say it's better in terms of, I mean, memory complexity, but in terms of time complexity, because we are using external memory here. So before, in the brute force approach, we did not have any memory, external memory. Yes, this is a better approach. You can look at it, and I have already explained everything, I think. Do you guys have any question?
No, in chat, we still don't have some questions, but a lot of people find useful this session. Thank you for your solution, Kuvonchbek.
Thank you.
Uh, Thank you for being there.
Yeah,
Okay,
I hope it will be useful for everyone. Thank you
yeah.
guys. Have a good day. Have a good
Have a
night.
good
Bye.
day.